Welcome dear students. Today we have week 9, lecture number 1. The course is Glass Theory and Computation. In today's lecture 1, we will cover about the non-deterministic finite automata, and then we have some example on non-deterministic automata. The short form is non-deterministic automata is called NFA or NDFA. So mostly in this lecture we will use NFA. Right? Okay. What is a non-deterministic finite automata? In previous lectures, we will know about what is NFA or non-deterministic finite automata. Right? We have the same principle or same element how to design the NFA, except we have alterable changes. So let's see it from the slide. What are those points, which is a different one. From the first point, we have NFA has the power to be in several states at once. Right. What does it mean here? It means that it can pass at a time to many states, right? In parallel, right? It can use the empty state. It can use transition wheel. So that's why it has the power to perform many transitions at one time. NFA is represented like a DFA. Why a DFA? Because we have some basic tuple or element for NFA as well. Like we were here, if you remember the previous DFA, so we have Q, which is the states. It could be initial state, or it could be intermediate, or it could be final, right? Then we have input symbol, then we have transition values, then we have the initial symbol, and then we have the final state. So we have almost the same tuple or elements for NFA as well, right? Further, we have over here transition is equal to number of states, the Q. Then we have the X, the transition values, and we have the summation, which is the inputs like 0, 1, A, B, and so on. So this is the language input sets, alright. Then they say we have to the power Q. Why to the power Q? Because we are using here subset of the transition states value. That's why it is the subset of Q. That's why it is represented by to the power Q. Transition symbol is a transition function. They take a state in Q. We already know about this thing. An input symbol and summation is the argument. It returns a subset of states. Right? Like we have the empty state as well. We have one or more states as well. Right? So that's why we have the transition function. So the transition function can start from initial state, intermediate state, and finally reach to the final state as well. So that's why we have the empty state as well over here. Next we have only differences between NFA and DFA is the type of value, that is the return transition value, right? A set of states in case of NFA, in a single state in case of DFA. So we have here the final states. In NFA we can have more than one, or we have more than one intermediate nodes, right? For NFA cases, right? For DFA cases we have only a single state, right? So it can go from one state to another state, conceiving some transition values, some transition function, right? So for NFA, so we do not require any kind of transition value. Even though we can use the empty string as well to reach to the final state. So we will see how we can implement these two steps in the community example, right? Okay, the transition diagram for NFA accepting the language of string ending in 0, 1, right? The basic condition we have over here, that is 0, 1, right? So first of all, before giving detail of this example, so we have to draw the desired diagram, right? So first of all, we just come over here straightforward, draw a diagram for any phase. We have state 0, Q0, Q1 and Q2. So we know this is initial and this is the final states, right? So we have 0, 1 condition ending with 0, 1, right? So we have 0 and 1, right? After that, there is a possibility we have the starting could be 0 or 1, or it's a combination of these two, 0, 1. So that's why we put it for loop on the Q not as well. So that's why. Alright. So let's see how we can formally draw the NFA equation, right? So it is very easy. We know from the condition 0 to 0 and 1, sorry, right? So based on this, we already know we have three states, right? It's dependent whether you present Q naught, Q1 and 2, or A, B, C, it's up to you. But usually in the practices of automata, we use Q1, Q2, and Q3 and so on, right? So over here, we can formally represent, we have three states over here, so we just mentioned three states. Then we have the condition wheel, this is the 0, 1, right? Then we have the transition, right? So we have three states, and we will pass these values, right, among these states through transition. This is a symbol why we have put it over here, right? And then we mention the final state, sorry, the initial state and the final state. So that's why we need to formally define the equation for NFA as well, right? But it's not necessary sometimes. It's, if we put it in the question paper or we draw by your side, so it's okay, right? But usually we also look to the NFA diagram as well. So this is the figure 1, right? So this figure 1 we will refer in the upcoming slides. Then we have the transition table as we have for D phase, so same over here for NFA as well, right? So keep in mind the diagram as well for NFA. So how we can draw the transition table for NFA, right? So over here we know three steps, the three steps in the transition values from a set of language that is 0, 1. We have put 0 and 1, right? So let's see. Start. We are, if for example if I want to it's 0 state 0 Q0, right, and I want to read 0 value transition 0. So how we can implement this thing, mean to say what are the states will usually be consumed by between Q0 and the transition value 0. So if we see from the figure, so it could be for 0, so it will loop over here for here, and Q1 as well. So that's why we have put it over here, Q0 and Q1. If we see for the transition value forward between this and this, so we have also transition value for Q0, the one as well. So that's why we put it Q0, which is repeating itself. So we put it inside the Q1, right? The Q0. Same for Q1. So for Q1, we do not have any transition. We put it empty. This is also empty string or empty values, right? Then we have the transition from Q1 to Q2, right? Q1 to Q2 continue 1, so 1, 1, okay. Then we have Q2, so for Q2 we do not have any kind of loop or transition with the final step. That's why we put it empty, right? So that is the NFA transition table. So let's see have further extension to this transition diagram for generic representation. Okay, so internally we want to see how NFA work, how it can read the different values. So according to over here, keeping mind the diagram is very important, right? We will be discussing related to the NFA in this lecture, right? So we already know we have three steps, right? They say Q1, Q2, how this transition processing values for NFI, right? So we already know there's a possibility between these two, right? So that's why we have Q not in Q1, right? So it can read the 0 over here from here and 0 from here as well. That's why we put it in the output 0 values. And this is struck. Struck means that has been not reached the final value because based on the condition it is the 0 1 value, right? Then again we have whenever we reach to the next transition state, whether it's Q1 or Q2, so we have to start from Q naught, I mean the initial state, right? So over here we have the initial state, then we have Q1 and Q2, right? So it is again stuck. So what are both values which has been read over here, right? So we have been read over here between these path, that is 1 and 0. So 1 has come from here and 0 comes from here because it will reach to this point. Next we have over here, so for here we do not have any kind of transition, so that's why we put it empty. Next we have again for same path, but we have to update the values, right? So finally if we see to this part and we have to reach the final, so we put it 1. So these are the processing values, like for example whenever we use stack values, push and pop. So how internally it works to push and pop some values. But that is the same concept over here, right? So we have not any differences between this and that concept, right? Okay, after reading 001, the NFA is in states Q0 and Q2. Since Q2 is accepting state, so NFA accepts 001. So this is why, right? So 001 means this is 0, 0 from here, this is for this, 0 from here, and 1. This is why 001, right? So this is a complete internal processing diagram for NFA, right? Now we have some standard transition function for NFA. If we already know from the basic cases, okay? So formally the transition function for NFA is defined. We have basic and induction, right? So in basic we usually include the initial state with the transition, right? So we have the transition function. This is the initial state. This is an empty string, and so we finally reach to the state. That is usually the empty the initial state, right? Then we have the induction. The induction, which is the generic form, and usually it takes us to the final state, right? So for that we have right to the generic form instead of to the specific value. So that's why we represent we will replace this transition with W, the empty string with W. So further we classify the W into two values, X and A. A the last values, like for example in this case we have 1. This is the A values, and this 0 and this 0 1, this is the representation of W. Hopefully you got what is X and what is A in this case, keeping the diagram on this. Right? So if we in the initial state mean the initial transition value, so how we can represent, because we have two combinations over here for generic form. So we say the transition function, the initial symbol, initial state, we have the initial values because we do not know X could be like 0 0 0 from this one, or maybe 0 1 1 1 and 0 and so on, right? So that's why it could be in any format. So then we have equal to Q1, Q2, Q3. These are the X actually are the different transition values. So that's why it is represented by these, right? Then we have the stage like this one, the 1 up to Q2. We can write this is the product value I equal to 1 up to K, right? Transition function, and this is the P being this over here, this Q1, these values and this value. So these are represented by P value, right? P value, and then we have A. So A over here, this value, right? After that, we have equal to n. So that is reach us to the final value, final state. So how we can represent these two generic reduction function into one function. So we can do very easily. Transition function to not is equal to r1 r2 to rn. So these are the generic representation of NFA in case of we have induction or more values. So we have another example over here. So we want to say the input value 0, 1, 0, 1, right? By NFA, keep in mind the figure 1. So we can design the generic form of generic diagram for this one. So let's see one by one. We start with the empty initial state and empty string. We already know transition function empty string q naught empty string is equal to q. So we written q naught, right? Then we have according to the function we have 0. So we put the 0, right? So whenever it be on the q naught and reading 0, so what could be the output? So there's two output, right? One output itself is this one, right? If we consider the loop, another output is it is q naught and q1, right? So we can write both, right? q naught and q1, and we can also call this one as well because we are talking about the 0. So let's see furthermore. Next we go to so 0, right? So if I classify q naught 0 union the common point, then we have q1 and 0, which they are talking for here, right? This is 0 and this is 0. So we got actually q1 naught and q1. Next we have some set of 1, so 1, right? So this should be repeated throughout, like if it's 0, so it's 0, if it's 1, so 1, if it's 0, so it's 0, both, right? So we will see how we can get the initial from the given figure 1, right? So over here we have the 1, so put it q naught with 1 and q1 with 1. Why we are selecting q naught and q1? Because we already know from the initial diagram, so this why we will accordingly, right? So after that we will get q naught union q2, and we can also run in this way as well. Next we have the 0. So we have the 0. This is q naught 0 and q1 0, right? The transition function, right? So we already know what it means. So it will read transition value 0 for q1 for here. It will read transition value 0 for q1, right? So that's why we have put it over here. So at the end we will get this function as well, right? The next we have the 1, right? So 1, so we put the q naught and 1 and q1 and 1, right? So if we see from here, so we will get the q naught and q2. Right? So this is how we can implement the NFA with any input processing values, right? Then we have some equivalency between NFA and DFA. So in NFA, there is a DFA that accepts the SAM language, right? So it means like this is the NFA diagram, so it will automatically work for DFA problem as well, right? So with the subset construction, so that will solve this one, right? The number of states of DFA can be exponential, and the number of states of DFA, right? To say the number of states of DFA can be exponential. Okay, the state in the DFA it increase is exponential. What is exponential? Like it could be sometime double, it could be sometime more states based on the number of input states, right? While in the diff and while in the fundamentals and NFA, we are really straightforward. We are just follow the condition value and that's it, right? That's why we have more states and we have more values from diff compared to the NFA. Thus, NFA accepts easily the regular languages, right? So there is also we are doing from previous lectures. We have another generic form how we can construct NFA to DFA and voices. We have generic form. Subset construction means that we have a condition with like 0, 1. We have a slide. Okay, so subset constructions are from NFA represented by N, and the goal is to DFA represented by D. So we can say language of D is equal to language of N. So it means DFA is also equal to NFA as well. So already about automata is right. Start state of DFA, D is start state of NFA N, right? We have start D for DFA and N for NSA. Other component of D are constructed as follows, right? So we know that QD is subset is the set of subset of NA, right? This is the whole set and this is the subset of Q. Like for example, Q of D is the power set of Q of N. We already know 2 to the power N. But yeah, we have it here, right? It is actually double because we know from here exponential growth, right? So that's why. So that's why we are using 2 to the power N steps. Part of this, the subset always will live in to the set video like to 2 to the power N. We have more generic form presentation. F of D is the set of subsets F of P such that so it means subset S belong to set of N which is not equal to N. We already know. What does it mean? It means, for example, we have 10 values and we have selected value number 3. So that value is S is equal to 3 and F of N is equal to 1 to 10 values. So that's why we have the S value inside F of N. So it will not be equal to empty. That's why they just said it is not equal to empty. Based on the example I will give to you. For each state, S belong to Q of N, mean the total number of states. Q of N mean total number of states, and S is the specific state, right? It could be initial, it could be final, it could be generated in each input symbol in a data set, right? So how we can use the form for this? So we can do very easily, write a transition function, which is a transition of D. S, which is the initial state, we say in this example, and A is the transition value is equal to the union, right? So P and S, where P is the specific tax value, right? And the set of S, right? So we can say the transition in P comma A. So we already know, right? So what does it mean? This is the generic form and this is the specific form if we give the real time values. Okay, this table also the transition table, right? We have the values, right? And then we have the steps over here. So we have some extra tags or label which represent only the steps, right? So what's happening in each steps? Keep in mind whenever we design the NFA, so we know these are the steps, right? These steps and these are the transition value. So to represent each state with the transition value, we give the tag or labels, right? So these are the label or tags, right? To represent the particular scenario or case or transition environment, right? So keep in mind we are designing this transition table based on the given figure 1, right? So if I say the initial, right? So initial we have like empty for in effect cases, if I empty, right? Then we know, so it's represented by A, right? Then we say Q naught. So Q naught, it also accepts the empty string if we know, right? Then we have Q naught and Q1, right? So Q naught and Q1, so it also accepts the zero from here, or zero transition between these two zero, right? And then we have Q naught, so it also accepts 1 as well. So it is represented by B. This is also representing the starting point as well, right? The transition starting point, okay? Next we have C, okay? So in C we have Q1, okay? So if we see Q1, okay? So it doesn't do anything because we do not have any transition, because we do not have any loop on this, right? So another point for other for 0, so we do not have any action, right? If we do Q2, so for Q2 it is 1, right? So how we usually draw these different combinations? So based on these combinations, right? Or based on the user inputs, user can give any value, so we have to see those values and draw this step, right? With the pair with the combination. So for here, this is Q2, it doesn't accept any empty string, it's an execution, then there is no loop on this, so I have empty. Then for E and lablet, we have Q0 and Q1, so it again doesn't do anything. So Q0 and Q1, so it do the 0 to doing this, right? Then we have Q0 and Q2, so 1, right? Then we have Q0 and Q2, doesn't do anything, right? Q0 and Q1, come to here, 1, 0, Q0, so it's 1, it's a loop over here, right? So same over here, Q0, Q1 and Q2 do anything, doesn't do anything, empty, and Q0, Q2, we have the 1, right? Then we have G transition, it doesn't do anything, right? Then we have Q0 and Q1, right? It do the transition 0, and the same Q0 and Q2, it do transition 1, because we have the final value reaching to here, that is called Q1. So let's start or draw the defect from the given combination, right? Or keeping the figure in mind. So here it is the section B, transition B. If you remember this one, transition B, or FRT or QB, that is the same thing, or here is the same, right? And this one is the especially this one. Transition B, Q0 is 0 units, right? We will execute a different combination based on this figure, right? This is Q0 with 0 combination, right? So it will give you possibility this one and this one, right? And then they execute it for considering state 0 to 0 with 1 value, so it will give you the Q0, right? Then we have the combination of keeping this table and this table as well. You can make different combinations, right? So we have Q0 and Q1, Q0 and Q1, we have 0. So we have because 0 from each transition is 0, it also is 0, so it's okay. We choose the SI series, then we have 1 between these two, right? So this one also 1, the loop 1, and this one also, but it will not accept the 1 because we have the transition 0. So we will automatically convert this Q1 in output with Q2 like over here, right? We have to keep in mind the transition between one of the states as well, right? Then we have a combination of Q naught and Q2, this one and this one, taking accepting 0. So if we assign 0 to this one and 0 to this one, so let's see whether it will applicable over here. So okay, or this is not so okay. But for Q0, Q2, it does not accept 0. So that's why it has been represented with Q1 because we have the transition 0 between these two. Okay, next we have NSA and DSA accepting the SAM language. Right? So the function, condition function, Q0 and Q2, it's 1, right? Means the whole this function will return the 1, really the 1, really the 1. So how we can prove, right? So we already know we put transition Q state Q1 transition value 1 and this one state 2 transition value 1. So we will see whether it accept or not, right? So according to the figure of this, we will compare this figure with this state as well, right? So if we see from here Q0 and Q2, so Q0 and Q2 is here, right? So we have two possibilities over here, 0 and 1, right? But ultimately we have to achieve the Q0. Why Q0? Because it will return only to Q0 and we need to reach to the Q0 taking the value 1 because the value here, the condition value is 1. So that's why, right? So this is the different DSA having the same language capacity, right? So this is the concept how we can make the generic form of NFA and DSA and the transition video transition diagram. Hopefully you understand. Thank you students so much.